Hello everyone. Today we are going to discuss about the topic directory implementation. This video is presented by Deepika and Sri Soumya under the guidance of Dr. M. Prasad Sir, Associate Professor, Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram. Now let's see about what is a directory. In the context of an operating system, a directory is also known as a folder. It means it's a container that is used to organize and store files in other directories. It provides a way to structure and manage the files in a storage device, such as hard device or a file system. Directories also serve as a hierarchical organization system where you can have subdirectories nested within to further categorize and group files. Directories are essential for maintaining order and organization within a file system, so that making easier to use and find and access and manage the data.
Let us see the key characteristics of directory. First one, hierarchical structure. Directories are organized in a tree-like structure with a single root directory at the top. Subdirectories can be created within other directories. Next one, file storage. Directories store files which can be of various types, including documents, programs, images, and more. Each file is typically contained within a specific directory. Next one, naming. Directories are given names to help users and the operating system identify and locate them. Next one, navigation. Users can navigate through directories to access and manage files. Operating systems provide commands and graphical interfaces to create, move, rename, and delete directories, as well as to list the files and subdirectories they contain. Next one, path. A directory can be uniquely identified by its path, which is a sequence of directory names separated by slashes or backslashes depending on the OS.
Okay, from this picture we can understand clearly about directory. In the first one, let's take it as a root directory in which we have many files and subdirectories. In the second picture, this is a subdirectory within the root directory. In that subdirectory also we can place many files and other folders so that we can organize the files and folders very easily and easy to retrieve through. Now let's see about directory implementation. The efficiency, reliability, and performance of a file system are greatly affected by the selection of directory allocation and directory management algorithms. There are numerous ways in which the directories can be implemented, but we need to choose an appropriate directory implementation algorithm that enhances the performance of a system. So, directory implementation in operating system can be done by using two ways, that is a singly linked list or hash table.
Implementation of directory, the first one is singly linked list. Here we implement a directory by using a linear list of file names with pointers to the data blocks. The implementation of directories using a singly linked list is easy to program but is time consuming to execute. To create a new file, the entire list has to be checked such that the new directory does not exist previously. The new directory then can be added to the end of the list or at the beginning of the list. In order to delete a file, we first search the directory with the name of the file to be deleted. After searching, we can delete that file by releasing the space allocated to it.
Now let's see about directory implementation using linked list. For this purpose, we are using singly linked list. Here, this is the pictorial representation how the directory is implemented using singly linked list. In the singly linked list, we can move only towards forward direction. We can't move towards backward direction. In linked list, everything is represented in nodes. Here, each node is divided into three parts, where first part holds the file name, and second part holds the data, and third part holds the address of the next node. Here we have pointers which points to the node. through the pointer, we traverse through the nodes, and we can retrieve the file name and other properties which are in the nodes, such as data also. It is easy to implement too.
Now, let's take a look on advantages of directory implementation using singly linked list. The first one is to reuse the directory entry. We can mark that entry as unused, or we can append it to the list of free directories. Next one, to delete a file, linked list is the best choice as it takes less time. Last one, the implementation of directories using a singly linked list is easy to program. There are some disadvantages in using singly linked list also. Some of them are, when the user needs to find a file, the user has to do a linear search. Next one, linked list implementation results in slow access to a file. It is time consuming to execute. And the last one, so the operating system maintains a cache to store the most recently used directory information. There is another method to implement a directory, that is hash table, an alternative data structure that can be used for directory implementation is a hash table. It overcomes the major drawbacks of directory implementation using a linked list. In this method, we use a hash table along with the linked list. Here, the linked list stores the directory entries, but a hash data structure is used in combination with the linked list. In the hash table, for each pair in the directory, key value pair is generated. The hash function on the file name determines the key, and this key points to the corresponding file stored in the directory. Using the keys, the hash table entries are checked, and when the file is found, it is fetched. All the keys of key value pairs in hash table should be unique, and there are no restrictions for values.
Now let's see about pictorial representation of directory implementation using hash table. In this implementation also we use a linked list in addition to hash table. For that we use singly linked list, which we can move in a forward direction only. In linked list we have a nodes. Here in node is divided into three parts, where first part holds the address of file name, and second part holds the data, and third part holds the address of next file. Here we maintain pointers which points to the nodes. Here, in addition to the pointers, we maintain a hash table with a key value pairs at the creation of a file itself, where each key in a hash table should be unique, and it means file name is stored as a key. All file names within the directory should be unique. We know that the traversing or searching operation in a singly linked list is difficult as it has much time complexity. Here, uh, instead of finding a file name by traversing through each node, we maintain a hash table so that all file names can be stored as keys, right? So we can easily retrieve the file name by searching in the hash table in the keys itself. The values associated with the keys, they have no restrictions for the values. They may be data or some other things.
Now let us have a look on advantages of directory implementation using hash table. First one, fast data retrieval. Hash table provides constant time average lookup, making it incredibly efficient for retrieving data. This is crucial in directories where quick access to information is often a priority. Next one, flexible key value pairing. Hash tables allow for flexible key value pairing, enabling the storage of data in a structured manner. This flexibility is valuable when dealing with diverse types of information in a directory. Next, efficient for large data sets. As the size of the dataset grows, the efficiency of hash table based directories remains relatively stable. Next one, dynamic size. Hash tables can dynamically resize themselves, adapting to changes in the dataset size. This automatic adjustment helps maintain a balanced load factor, ensuring optimal performance. Although there are having some advantages in using hash table, and also there are some disadvantages also. First one is collision handling. Collisions occur when two different keys hash to the same index. Dealing with collisions requires additional techniques like chaining or open addressing, which can impact the simplicity of implementation and potentially reduce performance. Next one, memory overhead. Hash tables may have a higher memory overhead compared to other data structures, especially when dealing with a sparse dataset. This is due to the need for maintaining an array that could be larger than the actual number of stored elements. Next one, hash function sensitivity. The effectiveness of a hash table is highly dependent on a well-designed hash function. A poorly chosen hash function can lead to clustering where keys end up in the same buckets, resulting in decreased performance. Next, not suitable for ordered operations. If the directory requires ordered operations, such as iterating through keys in a specific order, hash tables may not be the best choice. Other data structures like tree might be more suitable for such scenarios.
Okay, in summary, while hash tables offer fast and flexible data retrieval, addressing collision issues and select appropriate hash functions are critical considerations. They are well suited for scenarios where quick access to data is essential and the dataset is expected to be dynamic on. That's all for it. Thank you so much.